I work for industrial customers, helping them save energy. I've done this for 16 years now, and I think I've cooked the ways to save energy down into 4 basic areas. Here we have them in all their glory: reduce the load, improve the technology, upgrade part load performance, and use better set points and controls. Reducing the load is a familiar concept if you've ever raised kids in the summertime. The more they leave the door open, the more the air conditioner runs, and the higher your electric bill is. In the winter, it's no different, other than your furnace is running to replace heat that's lost from your home. If your insulation sucks, your furnace is going to run more. Reducing the load can often be upgraded gradually. You can teach the kids to close the door, you can seal up the cracks around the windows, and you could add insulation to your attic. Improving technology involves using equipment that handles the same load but uses less energy. Sometimes this is as simple as simply purchasing a more efficient furnace or air conditioner when you're buying new equipment. But sometimes it involves switching technologies entirely, such as switching from electric resistance heating to a heat pump. The best example of improved technology is lighting. The incandescent light bulbs of my youth put out mostly heat and only a little bit of light. This lamp uses 60 watts. This lamp puts out the same amount of light. This is a compact fluorescent, and it uses 13 watts of power. So that's a huge leap forward in technology. But the compact fluorescents are being eclipsed by LEDs. This LED uses 8.5 watts of power and puts out the same amount of light as the other two. Plus it lasts much longer. Many of the LEDs you buy today will still be in service in 2040 and beyond. Upgrading part load performance is a little more difficult concept. As systems get larger and larger, they're more likely to operate continuously and not cycle on and off like a smaller system in a home, such as a furnace or air conditioner. This introduces a new problem: part load performance. Let's say we have a pump that's supplying cooling water to a factory that runs all the time. The pump is designed for maximum flow, and its efficiency is probably very good. However, most of the time, the users aren't demanding maximum flow, so the pump spends most of its life operating at part load, moving a partial amount of water. Its efficiency can be terrible at part load. It might use 70% power to pump 30% water, for example. This situation occurs all over the place in industry with pumps, fans, and compressors, and there are a variety of ways to address it. One way is to use speed control. If we can adjust the speed of the pump, fan, or compressor, we can often make it much more efficient at part load. For example, our pump might use 30% power to pump 30% water. The last on my list is use better set points and controls. A system can have super efficient parts, but if it's operated poorly or has some setting out of whack, it will often use more energy than is necessary to get the job done. One example might be setting your air conditioner thermostat at 60 degrees all summer. Well, it's going to run a lot more hours set at 60 degrees than it would if it was set at 75 degrees. That's a simple example. Sometimes there are complex interactions. If we raise the chilled water temperature, it will save chiller power, but it will also increase the pump and fan power. So there's a balance to use the minimum amount of energy to get the job done. Gut reactions can be right, but sometimes they're wrong. You can probably tell that these are not neatly divided concepts. There's a lot of overlap. A bad set point, such as 60 degrees on your air conditioner, this is a set point problem, but it's going to lead to increased load on the cooling system. So these ideas are not cleanly divided. They were not born fully formed from the forehead of Zeus. but as far as I can tell, they cover the ways to save energy. So this is how we're going to save energy. We're going to reduce the load, improve the technology, upgrade part load performance, and use better set points and controls. Thank you.